Hello everyone, it's Michael again. So today we going to do a walkthrough on this lab training a machine learning model. So lab overview on this lab, you will continue exploring the biomedical vertebral column dataset. You will first split the dataset into three separate datasets for training, validation, and testing. You will then use this data to train a machine learning model by using XGBoost algorithms. Objective of this lab is after this lab, you will be able to split the data into training, validation, and test data set. Train a XGBoost model in Amazon SageMaker. Prerequisites for this lab that we have the system which we already have. So let's go to our task one. So accessing a notebook instance in Amazon SageMaker. In this task, you will open your Jupyter Lab environment and switch to the notebook to complete the lab. To open the Jupyter Lab, go to the AWS Management Console. On the Services menu, choose Amazon SageMaker. So we click into Amazon SageMaker. And then from the navigation menu on the lab, expand the notebook section and choose a notebook instance. We're going to choose notebook instance. Look for the notebook instance name my notebook, which is this one right here, and open the Jupyter Lab notebook instance by going to the end of the row and choosing open Jupyter Lab. So right here, we go to open Jupyter Lab. It is opening. Awesome. It's loading. Let's go back. Now for task 2, we are opening a notebook in your notebook instance. So in this task, you will open the notebook for this lab. In the Jupyter Lab environment, go to the file browser in the left pane and locate the tweet_for machine learning .ipynb. It's right here. Then open the this link, this file path right here, which I already did, choosing it. And the tip is, if a window appears asking you to select the kernel, select conda Python 3 and then choose select. Then follow instruction on the notebook. Awesome. So we now start follow instruction here. So overview, this lab is a continuation of the guided lab in the module 3. So in this lab, you will split the data into three separate data sets. Training set, this will be used to train the model. Validation set, this will be used during training to validate the model. Test set, this will be held back and used to produce the metric after the model is trained. You will use this data set in an upcoming lab. With the split data, you will train the XGBoost model by using Amazon SageMaker. Introduction to the business scenario. So you work for a healthcare provider and want to improve detections of abnormalities in orthopedic patients. You are tasked with solving this problem by using machine learning ML. So you have access to a dataset that contains 6 biomedical features and a target of normal or abnormal. You can use this dataset to train an LM model to predict if a patient will have an abnormality. About this data set, so this biomedical dataset was built by Dr. Henry Q. Mota during a medical residence period in the group of applied research in orthopedics GARO of the Centre Medical Chirurgical de Réadaptation des Massifs, Lyon, France. So the data has been organized in two different but related classification tasks. The first task consists in classifying patients as belonging to one of three categories: normal 100 patients, dyshernia 60 patients, spondylolisthesis 150 patients. For the second task, the category dyshernia and spondylolisthesis were merged into a single category that is labeled as abnormal. Thus, the second task consists in clarifying patients as belonging to one of two categories: normal 100 patients or abnormal 210 patients. Attribute information. Each patient is represented in the dataset by six biomechanical attributes that are derived from the shape or orientations of the pelvis and lumbar spine in this order. So we have the pelvic incidence, pelvic tilt, lumbar lordosis angle, sacral slope, pelvic radius, grade up spondylolisthesis. The following conventions is used for the class label: DH disc hernia, spondylolisthesis SL, normal NO, abnormal AB. For the information about this dataset, we can visit here right there. Dataset attributes. This dataset was obtained from DUA D and Graph C 2019 UCI Machine Learning Repository, Irvine, CA, University of California School of Information and Computer Science. So lab setup, because the solution is split across several labs in the modules, you must run the following cells so that you can load the data. So first of all, importing the data. So by running the following cells, the data will be imported and ready for use. Note the following cells represented the key steps in the previous lab. So first we import warning request zip file IO, warning simple filter, ignore, import pandas at PD, from spicy.io, import ARFF, import Boto3. Okay, so for the next code, we have this variable fzip aside this link right here, or aside to request get the fzip stream to true, vertebral zip aside to zip file .zip file io byte io content vertebral zip extract all. And then we have data, ARFF, have load, ARFF, have column to C, weka.arff, df assigned to pd.dataframe, and data at index 0. Then we have class mapper with these objects right here, be abnormal to 1, be normal with the value of 0. Then we have df class assigned to df class, replace class mapper. Then step 1, explore the data. You will start with a quick reminder of the data in this dataset. To get the most out of this lab, carefully read the instruction and code before run the cell. Take time to experiment. So first of all, we're going to use shape to examine the number of rows and columns. So df.shape right here. So we have some name error, df, name error, df is not defined. Next, get a list of column. Let's see what happened in here. Let me go to up here. You're trying to access a variable named dp that is not defined. Make sure you have defined the variable dp before using it. Take the example of how you can define data frame. Let's see. That's kind of weird because it's already defined here on top over there. Oh, something happening up here. To all requests HTTP name error, request is not defined up here. Oh, request is not defined. Interesting. Let's try this one first. Request is not defined. So we need to import requests, which they do not provide. Oh wait, request right here. Why it say request is not defined? The import request up there. Name error. Request is not defined. Interesting. Right here, it says request is not defined. Request. Now request must be imported. I guess I'm going to do a separate line of import request here. Try this again. Okay. Boom. Nothing running. You guys see six of them? Oh, I don't see 6 of them. Let's take this one out. Alright, run this again. Okay, it's work now. I guess this doesn't allow us to have bundle the entire request warning zip file IO into the same line. We have to import requests separately for it to work. So here we have the examine the shapes of this with a 30, 310, and 7 for the column. We have this index right here with this different type of column. So you can see the 6 biomechanical features, and that target the column is named class right here. So 1, 2, 3, 4, 5, 6. So these are the 6 different columns name. Step 2 is go to prepare the data. So for this lab, you must split the data into 3 data sets. An internet search will show how many different ways to split the data sets. Many code samples that you might find will split data sets into the target and the features. Then they will split each of those 2 data sets into okay, yeah, and then they will split each of those 2 datasets into 3 subsets, which result in a total of 6 datasets to track. So moving the target column positions, XGBoost required the training data to be in a single file. The file must have the target value to be first column. The file must have the target value be the first column, and the target column. Get the target column and move it to the first position. So we have columns assigned to df columns dot to list, and calls. We have calls at index from slice from -1 to the rest, and plus the columns from the rest to -1. Df assigned to df passing the column. Let's test this out. Okay, and then you should see that the class is now in the first column. Let's check it out. Now we see that the class in the first column. Let's see why that is. Right here we have df dot columns dot to list, and then we slice the original ones with 1. The other second one is from the rest to -1, and then this is our new columns, and then we should have class now in the front. Splitting the data. You will start by splitting the datasets into 2 datasets. You will use 1 dataset for training, and you will split the other dataset again for use with validation and testing. You will use the train test split function from the scikit-learn library, which is a free machine learning library for Python. It has many algorithms and useful functions, just as the one you will use. For more information about the function, we can check it right here. Yes, right here. And to learn more about the scikit-learn, you can check out this guide right here. So because you don't have a lot of data, you want to make sure that the split dataset contains a representative amount of each class. Thus, you will use the stratify switch. Finally, you will use a random number so that you can repeat the split. So from sklearn.model selections, import the train test split, then train test and validate assigned to train test split, pass it in the df, test size to 0.0, random state to 42, stratify assigned to df, pass it in the class name. And next, what we want to do is we're going to split the test and validate dataset into two equal parts. So test and dataset to train test split the test and validate, test size to 0.5, random state to 42, stratify to test and validate to class. Awesome. Now we're going to examine the three datasets because we're going to print out train, test, validate. So here it is. Now we're going to check the attributes of the class by using train, test, validate, pass it in the class, name, and then we're going to check the value count. So here it is. Now uploading the data into Amazon S3. XGBoost will load the data for training from Amazon Simple Storage Service Amazon S3. Thus, you will write the data to a comma separated values CSV file and then upload the file to Amazon S3. Start by setting up some variables to the S3 bucket, then create a function to upload the CSV file to Amazon S3. You can reuse this function. First, explore the function. Note the following line: data frame dot to CSV buffer, header to false, index to false. So this line write the pandas data frame, which was passed into the functions into the IO buffer that's named CSV buffer. You use a buffer because you don't need to write the file locally. To stop the column headers from being written out, use header to false assigned to false. To stop the pandas index from being output, use the index assigned to false. To write the CSV buffer to Amazon S3 as an object, use the put operations on the object, which is a property of the bucket. It's a bucket assigned to this. Prefix assigned to lab3, trains file, test file, validates file, import OS, S3 source to boto3.sessions.c source S3. We have this function upload S3 CSV, passing in this parameter 5 name folder and data frame, and this we have 3 different variable. We have first variable CS buffer assigned to io.string.io, data frame to CSV buffer, header to false, index to false, S3 resource dot bucket, pass in the bucket object, OS path joins prefix folder, file name, put the body assigned to CSV buffer dot get value. So we're going to use that function to create to upload the 3 data set, and then we go to upload. We go use this function to upload our data sets, the train, test, and validates 5. So now after that, we're going to train the model. So now that the data in the Amazon S3, now you can train the model. So the first step is to get the XGBoost container URI, and so we're going to import boto3 from the SageMaker message URIs. Import the retrieve container assigned to retrieve, pass it in XGBoost boto3.sessions .regions name 101. Next, you must get some hyper parameter for the model, because this is the first time you are training the model. You can use some values to get started. Use the estimator function to get to set up the model. Here are a few parameters of interest. So instance count, this define how many instances will be used for the training. You will use 1 instance. So instance type, this define the instance type of for training. In this case is ml.m4.xlog. So we will import SageMaker S3 output location to the string right here, format bucket prefix, XGB model assigned to SageMaker, estimator container as SageMaker, get execute role, instance count is 1, instance type is ml.m4 xlog, output path is S3 output location, hyperparameter is hyperparams, objects up there. SageMaker sections, aside the SageMaker sessions, and run the code. The estimator need channel to feed data to the model. For training, the train channel and validate channel will be used. So train channel, we have SageMaker.input.training input. We have this string right here. Format bucket prefix trains 5. Contents type is text CSV. Validate channel is similar with train input. Data channel, train channel validation, validate channels. Now running fit will train the model. So this process can take up to 5 minutes. So we go to run this. Start training the jobs. So after training is complete, you are ready to test and evaluate the model. However, we can do some testing and validation in later lab as well. So it's going to take about 5 minutes for this to run. What we can do is look at our code and wait for it to run. So starting the training jobs. So now it's preparing instance for the training. We're just going to wait for about 5 minutes and we'll be back. In the meantime, we can look at all the stuff: skits learning, machine learning in Python. I'll take some screenshot. So after waiting, the training is completed, and that is it for this lab walkthrough. I hope it was helpful. Thank you so much for watching and have a great day. Bye bye.